Good day, everyone. Today we will talk about lesson number 8.1, solve problem involving scale drawing. So word scale drawing is to reduce a shape or enlarge it. As you see here in the plane, this plane, okay, big one and small one. So the bigger one reduced to the small one with a factor. We are sure that it's a factor of reduction, or the smaller one become bigger with a factor too, from inch to feet. So I have the actual one, we call the real one, which is the actual. Okay, actual one, and the other one is drawing. We call the image drawing. Okay, so actual and drawing. Actual is the real one, and drawing is the smaller one, or the sample of it. Okay, so as a small example about scale is the maps. If I have the map of Egypt, say Egypt, yes, like this, okay. Okay, and River Nile, okay. Actually, it's not real distance. I can call it scale. You can find the map for Egypt like this one, and you can find it, you will find something that's called scale of 1 to 1 million, maybe something like this. This is the scale. So that means what? Each 1 centimeter over here, 1 centimeter, equal in real 1 million centimeter in real. 1 centimeter in the graph over the map equal in real life 1 million centimeter. So this is the meaning of drawing scale. I reduce it to see it easily. So I can measure it by ruler. I can measure the distance between two cities by ruler over, maybe between Alexandria and Cairo, something like this. Cairo here, مثلا, and Alexandria is here. If it's 3 centimeters over the map, so I can calculate the real distance or the actual distance because of the drawing scale. If you have the drawing scale, you can know the real distance. Now the distance is 3 centimeters over the map. Can you know the real distance? Yes, by the following formula. Formula says that there is a proportional relationship between scale and problems. How? So scale equal scale of drawing, the rule of scale of drawing equal is a ratio between scale drawing is a ratio between the actual length over the drawing length. Actual over drawing. This is the scale. So the scale equal actual over drawing. Let's take an example about how to apply it. Apply this one over drawing and real life. So the example should be, in the first example, will be here. The island in the blueprint here, architect engineering use the blueprint paper to draw their building and decoration, something like this over paper. Okay, but it's not real lenses. It's drawing, we call it drawing lenses. But we must have the scale. As you see here, I have a scale for the map, this small drawing. Its scale is 1 inch in drawing equal 1.5 feet in the actual life. So drawing scale is an enlargement or reduction or reduced drawing for an object that is proportional to the actual object. It may be reduction, like the map, and it may be enlargement, like the small insect. If you want to study small insect, we have to enlarge it. Okay, so we have to get a new scale. Okay, this is the rule, and we call the rule is scale over scale equal actual over. In our case here, scale equal 1.5 feet over 1 inch. Okay, this is the scale factor. Each 1 inch inside the drawing equal in the actual size 1.5. What if we want to measure this island? This island here in the drawing equal 6 inch. Okay, but it's not real. How we can know the real? Actually, by the scale. How? In the drawing we have 6 centimeter, and we call that the scale is proportional relation. So it's equal between two ratios, equal between two fractions. First fraction is the scale itself, which is 1.5 over 1 equal. So the up one is the actual, and down is drawing. I know the length in drawing, which is 6, but I don't know the length in actual life. So we can put L and use cross multiplication. So L equal 1.5 multiplied 6 over 1, which is equal 9. 9 what in the actual feet, exactly. So it's in length over the drawing length, it's 6 inch. But in the actual life, its actual length is 9 feet. Okay? Okay, this is the first example. Let's study the try it one. So, what is the actual width? We study the length, but we want the actual width now, actual width of the island if the width in the drawing is 2.5, so it's in drawing. So the scale is 1.5 over 1 inch. Okay, so I need the actual width, put W up. And I have the drawing, put it down. Make cross multiplication. Okay, so W equal 1.5 multiply 2.5 over 1. So W equal what? 1.5 multiply 2.5. We can calculate it. 3.25. Actually feet, because this is the real. Okay? This is an example of how to study the drawing scale or scale of drawing. Okay? Another example. Number 4. We will solve number 4. What is the actual? He needs the actual. So where to put the variable? Variable actual up. So X is up. Okay? And down is the drawing. So the scale is, he told me the scale is 1 inch equal 2 meters, so it's 2 over 1. And the length is, he needs the actual base length. Base length here is 2.5, so down 2.5. So the actual length is cross multiplication, X equal 2 multiply 2.5, which is equal 5 meters. So in drawing, it's 2.5 inch. But in real or the actual side is 5 meter. Another question. Another exercise. On a map, 1 inch, number 7, exercise number 7, 1 inch equals 5 miles. This is the scale. So he can give me directly the scale, he call the scale is, or he can say it by this way. 1 inch equals 5 miles. That means that the drawing scale is 5/1. Two cities are 8 inch apart. Actually, 8 inch inside the drawing, so 8 is down. Yes. Then I need the actual, put it up. Make cross multiplication. 5 times 8 equal 40 miles. Okay. This is how to solve a problem. Again, number 9. Number 9. On a map again, I have 1 inch equals 7.2. So the scale is 7.2/1 equal. Two houses are 1.5 inch apart. 1.5 is not real, not actual. It's drawn, so it's down 1.5. Part on a map. What is the actual? I need the actual, but x here. So the distance is multiply x equals 7.2 multiply 1.5, which is equal at the end 10, I think 10.8 miles, because this is the real one. Okay, this is the actual. Okay, another example. Number 11. The scale for the drawing of a tennis court is in 1 centimeter equal 2 meter. So this is the scale. 1 centimeter equal 2 meters, so it's 2/1. Okay. What is the area of the actual tennis? Area equal what? Area of rectangle is area equal length multiply width. And this is the length, and this is the width. But he needed in actual. So I have to convert from drawing to actual first. Let's convert length. So L over, the length here is 10. So that means L equal to the cross multiplication. So it's 2 times 10, 20. In real life, 20 meter. And the width, the same as for the width, 2/1 equal W over the width equal 5.5. Then width, real width, actual width equal 2 multiply 5.5, which is 11 meter. Okay. What about the area? Area equal length in actual life multiply width, which is equal 20 multiply 11. And at the end, 20 multiply 11 equal 220 meter square. So first, we change from the drawing scale to actual scale, okay? Then we multiply them to get the area, okay? Okay, another question, different something. You may need to draw an image, okay? Then someone asks you, please enlarge it. I need it over a bigger paper. So we will change the scale. I have all the scale, and then I want to move it to new scale, like this example. The original blueprint of concrete patio has a scale of 2 inch over 2 inch equal to 3 feet. So the scale is 3/2. This is the first thing. Victoria wants to make a new blueprint with a length equal, so this is the old one. A length here equal for old, okay, 14 inch. And Victoria wants to make a new one for 16.8. So new 16.8 inches. Okay? This is the information now. What is the question? What is the scale for the new blueprint? I need the scale. He asked for the scale. And the scale equal what? Equal real or actual scale equal, we know that scale equal actual over drawing. Okay? But I don't have any actual here. What about, let's get the actual length from the old drawing. We will get the actual length. Actual length from the old drawing, so it's the old drawing has the ratio 3/2 equal actual length over and 14. Okay, so the actual length here equal cross multiplication. It will be 3 times 14 over 2. It will be 3 times 7, 21 feet. So the actual length is 21 feet. What about the new scale? The new scale is actual over drawing. So we will make a relation between the actual and the new scale. So the actual, the scale, the new scale can be written as 21 over 16.8, okay, which is equal at the end which is equal 14.4 inch in the drawing. Okay, so the new scale of drawing is 14.4. Again, to solve a problem, change from scale to scale. How? What is the steps? Steps is find the actual lengths from the old scale. Okay, as we did up, we found the actual length. How? By using the old scale. Okay, by using the old scale, which is 3/2 equal the actual over 14 from drawing. We get it from drawing. Okay, and we get the actual length, which is 21. Also, we want to get the actual width. Actual width, we get it down here. Actual width, we use the old scale and found from it the actual width equal 18. Now I have the actual length and actual width. What is the second step? Second step, find the new scale, which is actual over drawing. From where I can get the new drawing? He gave it in the problem here. 16.8. 16.8 is the new scale. So I will use the real actual length over the length in the new scale. It will give you the new scale. Now I have the new scale. Third, what do you want if I want, after I finish it? Find the other lengths of the scale if you want, so we can find the lengths and widths and any other lengths, and we can calculate, actually, if he want to calculate the area or the perimeter, we can use this new dimension. This is how to translate from or change from scale to scale. Okay? You must follow these steps and you will find it easy, inshallah. It's nice to be with you. I hope you enjoyed the lesson. See you. Bye.